So now that we've all started thinking about tectonics and reminding ourselves what the early ideas were, we're starting to get into the big ideas and thinking about specific areas on Earth like the seafloor. So that's what we're looking at here in this activity. Just a few intro questions to make sure we've grabbed everything that we need to so far. So the first one here is referencing our map activity, continental drift hypothesis. Remember, continental drift is that original theory saying that the continents moved over time based on those fossils and rocks evidence, which was pretty strong evidence to show that they were connected at one point, but Alfred Wegener was missing something. And so what was wrong with his thinking so far is he wasn't able to explain how the continents moved. He had no evidence specifically connect to how they were moving. So when we think about that, that's really our question moving forward, is how do the continents move? We have great evidence showing they were connected, but we don't have the way that they moved right now. So that's what you're thinking about here. What other things could we look at on Earth to determine if and how the continents moved? So what other land masses, features, details, what else would we want to know? And we had a question like this earlier on the map activity. It was that question number 9. We talked through it together and some of those ideas. So what else could we figure out to get those ideas? And we did take a step forward in the direction about the age of the Earth, and that was our radioactive decay activity. So what is it and how does it tell us about the age of the Earth's crust? What we're doing in radioactive decay is looking at the transformation of these radioisotopes over time from that parent material to daughter material. So when we think about what is radioactive decay, we're determining the age of the rock based on the amount of radioactive to non-radioactive material. Or we're figuring out the age of the crust by comparing the parent to the daughter material. And so I can figure out how long that rock has been, quote unquote, living or existing on Earth based on that comparison. So that's a key in our discussion today of where all these ages are coming from. So you do have a small intro paragraph to look at here. It says, before we begin. So now would be a great time to pause and read through this paragraph. And then you can start looking at the maps and answering the questions. So now that you've read the intro paragraph, you should be able to answer these couple questions here and make a few observations about this map. I always like to explain this map a little bit because it is tricky to observe. Normally we're used to seeing the land all color-coded, but here we're looking at the ocean color-coded. So just to get you oriented, this is North America, South America, Africa, Europe, Asia, Australia, right? That's the land. So what we're looking at are the oceans. And the oceans all have age data shown on this map. And the age information is right here. So we're looking at the red being the youngest aged rocks, 0 to 20 million years old. And we're looking at this pink or purple being the oldest rocks, again, 260, 280 million years old. So quite a span of time. And we're able to figure out those exact ages through that radioactive decay. So when you're thinking about observations on the map, things you could be observing are, what do I notice about the amounts of young compared to old? Where is the young at compared to the old? Do I see any patterns forming? Sometimes we get stuck on observations because it just seems too obvious, but it's like you're describing this to someone who can't see it at the moment. So what details are you noticing, just to get your brain thinking about this map? As you go through, each page has a few questions with a corresponding map. So this is map 1, questions and diagram. Map 2, questions, diagram. And map 3, questions, diagram. Each one has that age range bar for you to look at, and each one has something pointed out on the map to do a compare or contrast. Like our other explore activities, some of the questions are about the diagrams. What is the pattern? What is happening at A? What do you notice at B? But then some of them are taking it to the next level. Why is this there? What might be happening? And that's where you want to make sure you put something down, thinking about our discussion so far and about how those plates might be moving, okay? Only wrong answer is those blank ones or the I don't knows. So come up with something related to what we're talking about and just get an idea down about what might be happening to create these patterns that we see in age. As always, reach out with any questions you have.